Our next oligopoly is Stackelberg. And in this case, the characteristics are, again, few firms. That's what oligopoly is. And they can manufacture either a differentiated or a homogeneous product. But here's the difference. There is a leader. The leader then chooses an output before others move. Then based on that move from the leader, the others then react. So in this case, there's not this dynamic back and forth. There's a leader and a reaction. Here we see where we would have been if we were Carnot, right? That's just to set the base case. But here we're going to do something different. Here we see that the leader is going to move to the point where they can get their maximum ISO profit and yet have a position that suits firm 2. And that is determined by this green line where you can see we're moving closer and closer to the monopoly position for firm 1. And then firm 2 would then be out here on their reaction function. So the reaction function for firm 2 then leads to this new position for their ISO profit. And look how far it's moved away from the ISO profit for the Carnot equilibrium. So it's moved all the way from this point to this point. So they're actually eroding quite a bit of profit. And again, similar, look at the position for the leader for firm 1. They've gone from this equilibrium in Carnot to this equilibrium under Stackelberg, under their first mover advantage. So that's the definition of Stackelberg equilibrium. It's the leader making a move to their best interests, and then the followers follow and do the best they can. So this is nowhere near as dynamic as Carnot, but I think you see the reaction of an industry that is led by one of the firms. Here are the formulae for Stackelberg oligopoly. So we have a demand curve, cost function, which leads to the quantity based on the reaction functions of both the leader and the follower. So we'll do a quick exercise using these relationships. Here's some data. We have an inverse demand function for the two firms where P equals 50 minus the sum of Q1 and Q2. And the costs are 2 for both the firms. Firm 1 is the leader, firm 2 is the follower. And the questions are, what is the reaction function for firm 2? What is the output for firm 1 and for firm 2? And what is the market price? So the reaction function for Q2 is equal to A minus C of 2 divided by 2B minus 1/2 of Q1. If we plug in the numbers from this example, the A minus C divided by 2B, it leads to 24. Again, we'll do a more elaborate example later. Minus 1/2 of Q1. And the leader's output is given by the function as A plus C sub 2 minus 2C sub 1 divided by 2B. In this case, putting all those numbers in, we end up with 24. So now we have the leader's move, which is at 24, and now we can use the reaction function for firm 2 to figure out what they would do. So the leader does 24, and in this case, plugging the 24 back into the previous reaction function, we get 12 as the follower output. The market price, going into the formula above, price equals 50 minus 24 plus 12 equals 14. And the profit would be higher for firm 1 because of their early entry and their grabbing of the majority of the market. The next scenario is a Bertrand oligopoly. And this condition where, again, few firms, then here we have identical products at a constant marginal cost. So these are very important constraints or conditions, identical profits at the same marginal cost. Next, the firms are engaged in price competition, and they react optimally to what the other firm is doing. What happens then, as you know, is each firm will seek to build their quantity to the point where marginal revenue equals marginal cost. And what happens is they will then compete with each other to push and fight for the volume because they want to seek MR equals MC. Consumers have perfect information and no transaction costs, so they quickly reward the one with the lower price. So we get this very fluid and efficient bidding almost to the point where we have a very efficient market where the firms are battling it out and the consumers can freely choose the lower cost for them. The equilibrium in this scenario is that the market will then be such that the firms will compete and undercut each other until all the limit is raised. And that limit happens where the price of firm 1 equals the price of firm 2, which equals their marginal cost. And at that point, then each firm cannot move anymore, because if they cut volume any further, they will not make the same level of profit. If they increase volume beyond that, they're going to be in the negative side of their profit function, and that won't work for them. So there will be an efficient, socially efficient optimal here, where the consumers get at cost, right, at marginal cost, their product at a lower price, and the two firms make zero economic profit, but they're in business.